Sally again in a new session where we learn about C Sharp from scratch. We started this series with, just learning how to define variables. We went into lists, we went into modeling and simulation, and now we're in the realm of building enterprise level, end-to-end applications through APIs and UIs. And the last time Sally and I were together talking, we basically were talking about, how we can handle exceptions. And we talked a little bit about, being able to go in and localize and categorize exceptions. We talked a little bit about the categorizations. We basically said, okay, if you're going to categorize some exception, we have a couple of exceptions. This is an invalid exception. So there's this guy. When we go up in here, we basically went and said, if you have a book service like this, we want to categorize those. These are already localized, but they are not categorized, right? These are localized, but they're not categorized. So we went in and said, okay, we need to wrap this up in a validation exception. We want to add in a validation exception. So let me sync up because I think Sally already did the assignment. She basically went in and said, here's the deal. I'm gonna go and add in all the localization characters. You even did this one. I didn't even ask you for this one, but you did it anyway. Nice, nice.
No, you did it yourself last session.
Oh, I did.
That
I don't even know.
was
Okay,
the part we learned. Actually, you teach me that part about localization and categorization.
okay. Well, yeah, okay. So thank you for your honesty. You could have just taken the credit and said, "Yeah, totally, dude. I did that stuff. Totally, old man. Whatever you think." Okay, this is great. This is all good stuff. So basically we went and said, "Okay, we want to pick up this guy and wrap this guy in a validation exception." Right? What that basically means is that you have the categorization that will basically help us determine on the category level, what to do with all the exceptions that are under validations. And then from that onwards, we basically went and said, unless it's an exception, then let's wrap it up in a failed book service exception, and let's wrap that in a book service exception. Okay, so Sally has some insights. She basically said, I made it pass, but when I changed the test, let's go and see what this test looks like. I think she might have found a bug or something. Let's see. So, Sally, what was the issue that you saw? This here is the validation exception. Should throw validation exception. This is basically what you did. You went and said, okay, this is a null book exception that's going to be generated. No need for empty lines unless you want to do a symphony kind of thing. So that would be more persistent with the overall look and feel. But you basically went and said, here's a null book exception that will eventually be generated, and it needs to be wrapped up in a book validation exception. And we basically went here and we said, this book validation exception, we're gonna compare it to same exception as, right? And then here we basically went in and we said the messages should match, right? So what is it that you observed? You said if you go ahead, you tell me what is
Not,
it that
not for this one. Actually, go back to the um, invalid book exception, not for null. For null is okay. For invalid book exception,
okay, let's go for
so,
invalid book exception. Let's go into
mhm,
for the ad, right? This guy here.
yes.
Mm-hmm.
At the end, so
Mm-hmm.
if, for example, I put same exception, if I comment that,
You
uh,
comment this guy here like this.
yes,
Mm-hmm.
and then so now it passed. But if I change my book service to the previous version, basically I didn't have previous version. I didn't have book validation exception, right?
So if we go here and we say instead of wrapping it in a
Yeah.
validation, let's just throw that exception
Yeah,
directly.
just throw that exception.
Okay. If I run now, you're saying it's gonna pass.
It's gonna you comment that out. It's gonna pass. Yeah. Hold on. No, it's fair. Should
It's gonna
fail.
fail.
Yeah.
Okay, so if I go here and say this is, because remember, you still have to validate the data too,
Mm-hmm.
and your actual exception, hmm, Your actual exception doesn't have the data anymore. It's the inner exception that has the data in. So that's
Mm.
why it's gonna fail. Let's try it. Let's give it a shot. So this,
Okay.
yeah, check this out. If you go up in here and run this, this is gonna fail because what you're comparing against is not the same anymore. Check this out. See, why is this failing? Because the reality actually, what's actually should be equivalent is that the inner exception of this guy versus the inner exception of this guy.
Mm.
Let's try it. If I run here, actually, it seems like it's also
So,
it's
you
throwing
know,
invalid book exception.
no,
This guy.
no, is
Mm,
so when I with this when I commented out, so
mm,
when I unwrap the book validation exception on the book service, then it
mhm.
pass, right?
Yeah,
And
mm, mhm. You see, what I'm saying here is that if you okay, let's see. So this is actual invalid book exception.
mm,
And then the expected here is not gonna be this guy, it's gonna be the inner exception. Yeah, this guy should pass. Let's see. You agree? I think it would. Let's see. There you go, it's passing.
yeah, while we didn't check for the message, right? We checked the
Yeah,
date. We didn't
yeah,
check.
but we checked the data. Well, you don't have the code that checks for the message in here.
Yes. So I was
Yeah.
expected it should fail because we checked for data but not the message.
No, the failure will be based on what we ask it to check for. If you didn't check for the message, it's not gonna fail because you didn't check for the message. You have to say check for the message so it would fail if the messages are not the same.
Oh, hold on. Same exception as it
This guy
doesn't check
here.
for the message. Yeah. Uh,
So this guy's not gonna fail, you're saying? Okay, let's
oh,
try.
okay. Yeah. Yeah. No, it's
So
not gonna.
this guy is the inner, and our expected is the book validation. This guy definitely is going to fail, 100%. Check it out.
Oh, it does. You're right. No, it does now.
There.
Right.
Yeah.
Okay. So hold on. Let me think about
So why
it.
is it failing? Because this is an inner and this is an outer. The outer is the one that you're putting in here, and the inner is the one that we're throwing right now.
No, I totally what lost what I was confused about.
Okay. Okay.
You think,
Anyways.
and then
Mhm.
I will come back.
If it comes back to you, okay. So other than that, you asked me a question earlier. You said, Hassan, how do we know the difference between how to handle what, right? Something, how do I know it's a dependency validation exception? Can you repeat that question so people
For
could just
example,
understand?
we say like already exit student exception is a category of dependency validation exception. I want to know like when we say about localized exception, how would I know it belongs to which category? How would I know, for example, failed email exception in the category of dependency exception rather than being dependency validation exception? Kind of
Ah, that's a
it's.
great question. Okay, so hear me out. A validation exception is
Mhm,
something that's pointing out to something you passed in as an input. So let's just assume here you have this database, okay? And you have a service in here that's passing an object to this database,
mhm,
right? If the database goes and says, no, now watch this. If the database goes and says, hey, wait, I already have this object in here. This is your object.
mhm,
I already have this object with that exact same key in my system. So the
mhm,
database is saying the thing that you passed in is bad. It's broken. That's one. That's a dependency validation exception. It's basically going and saying the object that you're passing in has a key that matches an existing key and you're trying to add a new key in. Boom, it blows up. It says you can't do that. Or you're passing in the object and the object has a reference to another object that doesn't exist. So for instance, you're passing in a student object, and this student has an ID. Great, the ID is fine. But the student has a reference to a parent, but the parent is not on the system. So the database is gonna go and say, wait a second, this parent ID that you passed in, no, there's no record that matches this parent, so this request is failing. Okay, what's an example in also on the API? Let's say you're going and calling an API endpoint like this, and you're going and saying, hey, send that object to the API, and the API comes back and says, hey, the name attribute on this object cannot be null, empty, or white space. The name, let's say you're passing in a student model in here through the API, and you're passing in, okay, the ID is good, you're passing in an ID, but you're supposed to pass in a name, right? But it says this name cannot be null, empty, or white space. So that's a dependency. This is the dependency here.
Mm-hmm.
And the response is a validation response.
Let's see. But hold on.
Eh,
Previous one was a student. Oh, the reference didn't exist. I see the dependency. Okay, I got it.
mhm.
Mhm.
Let me ask you a question.
Sure.
So let's say I'm sending a request to the API, and the API comes back and says, this object is not found. You're trying to retrieve something from the API, and the API says this element that you're trying to retrieve is not found. Is this a dependency exception or a dependency validation exception?
Mm, I guess both dependency validation exception.
Exactly, because you passed in an ID that's broken, right?
Mm-hmm. Exactly. And
Okay,
also,
another. Go ahead.
it's not fun. Like the reference doesn't exist, right?
Exactly. What
Mm-hmm.
if you are trying to connect to the API and the API says 500 server is down? Is this a dependency exception or is it a dependency validation exception?
Dependency exception.
How come? How did you know?
Because you said some service is not found, some reference doesn't found, something like that, right?
So it's because it's not something that you passed in that made it error out. It's already erroring out on its own.
Mm-hmm.
So here's the golden rule for you. If something is server fault, client fault, there's
Mm-hmm.
service fault,
Mm-hmm.
client fault. What that means, if you are sending in all object, that's bad. That's on you, right? If you're
Mm-hmm.
sending in bad reference, it's on you. What about here? If the server is down, internal error, that's on the server. If you are sending in, you're going in and you're saying your server exceeded sorry, let's say something like failed dependency
Oh,
on the
depend.
server, right? So the server is saying, hey, I'm supposed to call this other service, but it failed. I couldn't
Mm-hmm.
connect with it.
Mm-hmm.
So this here is dependency exceptions. This here is a dependency validation exception. That basically you're going to the server and the server says something is wrong with what you sent me. I don't have anything wrong with me as a server. It's what you sent to me is broken. Okay, so that's a dependency validation versus dependency exception. Dependency validations mainly are things that are pointing out issues in the request itself. You're sending in an object, that's a request. It's saying this request is broken, something is wrong with it, versus the service itself saying I'm down, I'm unable to function. What do you think?
think I got it, but yeah, I would like to have more tests to figure it out. I totally.
Now we're talking. See, talk is cheap. The
Mm-hmm.
code is the only way that you can tell
Mm-hmm.
something is actually materializing or not. Okay? Okay.
Yeah.
Let's go into okay, any other questions before I move on?
I think for now is this. Yeah, I'm good for now.
All right, perfect. So what's the next step here? So we went in and we said, oh, there is validation exceptions, there's dependency exceptions, there's all these different exceptions that come in.
Mm.
Then when are we supposed to use a dependency exception? You know, the problem here is that looking at this code right now, we have a little problem. What is the problem? That, the dependency that we're using is in memory. So we're not really using any external resource. So it's very likely that this in memory is not really throwing or not really adding, is not giving us any particular exceptions that may come out of it, right? Sometimes we have to go into the source code. Usually, people, when they document APIs that people don't have access to, they go
Mm.
like this and they say, okay, people are not going to have access to my code. So here's all the parameters and here's all the exceptions. Here's the exceptions that can happen, right? Here's all, for instance, not found exception, something like this, right? And it goes and says, yeah, I need to document that so people know what I mean when I need to encapsulate exceptions. That's how properly, if you're exposing an API, that's how you probably document so people know what kind of exceptions you're going to be throwing in
Mm.
here. Unfortunately, the the APIs on the iQueryable, the .NET APIs in general, they need a serious revamp. Even this new .NET standard and all that, they need a real serious revamp. So how do we know how things are working? I go to this website called source.net. Source.net. My friend Shemi Wits Handler told me about this, and it's very useful. If I go to iQueryable like this, and that's your interface, and you have all these little details, this is where people kind of try to, document all the little things. I'm just trying to find a place where they would potentially give us what kind of exceptions you would throw when you go and say add. It's probably on the list itself. Let me go to IEnumerable.
Mm.
And IEnumerable, this is the source code of basically these APIs that we're using. This is how you go and say, oh, what is this? What kind of exceptions is it throwing and all that? And I'm basically really looking for the function that says add in here. And that function is basically what's going to help us know what exceptions this dependency could potentially throw. Let's see, something like this, for instance. I don't see any exception handling, unfortunately, but let's see
Yeah,
here. We
indeed, that was my this question came to me like, how many exception I should know I have to do, like now you're looking for one to see
Mhm.
if it's add draw one, but what is that the like general strategy for that?
There is normally, if people are properly documenting their software,
Mm-hmm.
you'll be able to know what exceptions they're throwing so people know how to handle them. But unfortunately, there's also situations where people are just not going to tell you, they're not going to tell you what exceptions are coming out of the system. And that's just poor engineering. That's
But
just
as a developer, like I handle those exceptions, right?
we have to handle them because if you don't handle them, they're going to break your system. You know,
Exactly.
this is why we do this catch-all kind of thing. This is why we go and say catch all. Why catch all? Because we want to go and say, well, if we don't do catch all, what's going to happen is that there will be an exception that we've forgotten about,
Mm-hmm.
and we don't know how to get to that exception, and now we have to basic.
I
uh,
wanted to ask, like, how would I make sure I wouldn't forget any exception?
You're gonna have to research. Some places will basically tell you, some documentation, some libraries will tell you what exceptions they're throwing, and some others won't.
Oh, let's see.
Yeah, that's the tough part. The tough part is to be able to be aware. And also you can, because you're catching all, You know, you can put like a generic rule to catch everything, but the most, wow, this is all if statements. Nice. This is why this entire library needs to be rewritten. There's a lot of things in there that I don't necessarily agree with, but in general, what I'm trying to say here is that, you know, if you are interfacing, this is why we're trying to really protect our core logic from, this is why we're doing this localization and categorization, because there's like mayhem out there, you know, that is unpredictable. It can cause a lot of issues, and your job is to basically think of your code as a castle, and you're trying to protect it from being attacked with different errors and different exceptions. Now, here's what I can do though. I can go here and say, let's go to Microsoft documentation, iQueryable. Let's see, maybe in the, maybe, I don't know. Maybe in the documentation, they'll tell us what kind of exceptions are being thrown. There's properties, extension methods, and that's it. Nice. And if I go here, properties, methods, extension methods, lots and lots and lots. Let's see, the one that says add, adds a value to the beginning of the sequence. That's prepend. We want the add, iQueryable add. Let's see. So this is, and I think it might be just IEnumerable. Let's see if I can do IEnumerable and IEnumerable methods, and there should be add here somewhere or insert or something, right? We did say add though, right? So oh, it's a list. Okay, so we said our book is a list. Let's see on the yeah, let's see on the list realm. So there's generic list. I just want lists. This guy. So here's the list. And does the list throw a particular exception? This is iList, I guess. Do we have add? Yeah, there it is. This is the one that I'm looking for. Now, there is not supported exception. That's the only thing that this guy is throwing, at least what's documented about this guy.
Mm.
If I go and search for this in the source code, would I be able to, so source.net, if I go and find this guy, does it actually find it for me? I hope so. We'll see. Public key. Yikes. It doesn't know what it is. What if I kind of, nope. Let's see, add T item. Nope. Doesn't know what it is. MS build. What if I say iList? So this is field iList. Nope, that's not it. I'm looking for a class. Interface iList source. Where's iList at? Interface iList. And then do we have the add here? Nope, it just has insert because it inherits from collection. What about just list instead of iList? Because that's really what we're interfacing with. This guy here. So this guy should have something called add in it. Is this the same guy that we're using? No, this is from Windows documents. We're looking for system collection. So let's see here if we can find system collection because this is where we got that list from. So let's see here. These are fields, fields, fields. We're looking for class. Yeah, this guy here. This might be it. There's your guy. And this guy here, there's a function called add. There it is. And what am I looking at? So you pass in the thing and it throws not supported exception. Well, that's wonderful. That's fantastic. There's insert. Hmm. Yeah, the best thing to our knowledge is that this thing is throwing not supported exception. Wait, is this the actual list though? No, that's not the list. Okay, hold on. There should be one more out there that we don't know about yet. I'm basically looking for one that is basically, let's see, we'll find it. So this is a part of this. You're gonna kind of need to find in displaying. Oh, I see. Okay, let's see. System dot collections. I want to see where, so a list comes in from a system collections dot generic. System collections dot generic, like this. Okay, and this is all we have. Array sort helper. Yeah, I can't find
It has non-generic
generic class connector. So if I say just list T, that
class.
should, yeah, that should kind of filter them out a little bit. But yeah, see, I can't find, this is the core lib, and this is list. Do you see add in here by any chance? Let's see, add.
You
Yeah,
pass it.
there it is. And unlucky for us, it's not handled with a try catch or anything. So I don't really, let's see, maybe there's other places. Nope, that's it. That's your guy. Add function, add ilist, add object.
Yes, exception. What
So
is that?
there is invalid cast, but this is not a method. Yeah, really, seriously, the list, the only thing that we're looking for here is, so these are all usages. This is it, the method that we're looking for.
Mhm.
I think. The one thing I think also is not, so does it actually return void? Yeah, it does. Wow, this is the one. So this guy goes and adds to an existing array and it does a size and all that kind of stuff, and then add with size. And what does add with size does? It does this stuff and then grow. Yeah, all of this code is just, yeah, there you go. So anyway, I will take unsupported exception. I'm assuming that not supported, I know I shouldn't take not supported exception because it's basically not what we're trying to go after here. Anyway, so in our case here, there isn't really something that solid that we can rely on that can tell us what an action like this could produce. We don't know, right?
Mm.
Because the documentation is so poor, we don't know really. Like if I open this guy like this, technically it's supposed to tell you, what exceptions you would probably expect to pass in there, but it's not. In fact, actually, if you run this C# interactive and you go and say list string strings new list like this, and you go and decide to go and say, which is okay, strings dot add, and then you pass in a null in there, I think it'll be just fine because it's a valid string value, right? How can we possibly break this? I have absolutely no idea. If I go and say, I don't know, if you put a number in there, it won't even let you. Like it won't even let you continue. So in our case here, there is no good case to go and say handle dependency exception. So we're gonna skip that one. We won't have to do dependency exception. But here's what we can't skip though. We're gonna build a new thing in here called logging broker. Logging broker. So I'm gonna go here and say loggings in here. And I'm gonna go here and say I need an interface, iLogging broker, and I need an implementation. I'm gonna put the implementation together and I'm gonna tell you what this logging broker does. Logging broker, like this. And this logging broker here basically does things that are really important for the work that we do here. It basically helps the engineers understand. So for instance, there's something called log error, right? And you want to go in there and say, I want to log an error with an exception. So an exception happened of some kind, and I want to log this error that was caused by that exception. What's the point of logging? Why do we need logging? Take a shot at it. Why do you think engineers need logging?
Still, I'm confused with the meaning of login here. Wait, I'll check.
So if I told you that logging basically is your ability to have a record of every single activity on the
Oh,
system on your software,
okay.
why would logging be useful for us as engineers?
Mm, the engineers have a record of all those exceptions, for example. Uh,
So let me tell you why logging is important, and we can just make this session just as an intro to logging. so
Mhm.
we understand what's happening. If you have a system like this, it doesn't matter what the system is, you have a bunch of components talking to each other. And these components are going like this and they're talking to each other. Okay, great. Your client that's trying to consume these components might be doing things on the system, or the system itself might be doing things underneath that may or may not be successful. They
Mhm.
may or may not be successful. So let's say this is a consumer, and let's say this is storage. Consumer and a storage. And these two things are communicating, and let's say maybe this is a controller, and maybe this is a service, and this is a broker. Okay, here's what logging does. Logging will come in and say, anytime, think of it as a substrate like this. Anytime anything happens on the system, give me a notification, like let me know that something has happened on my system. Like this, like this, like this. What's an example? When a request comes in, it will go in here and put a record like this that says request came in. So request received. Request received like this. So this guy is logging here saying, hey, at this hour, at this minute, I received a request that has this particular information. The service will say, request processed, right? Request processed, meaning I received this request at this hour and I was able to basically process this request successfully at this hour. And then when it goes down here, this guy will say request persisted, right? Request persisted, I was able to handle that. So when an engineer is trying to investigate, this customer here might come in and say, hey, I used your API and your API is not working. The engineers have access to this substrate, to this file here, that basically help them investigate. It's like an investigation. Help them investigate all the events that are happening to the system based on what this consumer is saying. Engineers use an indicator as a reference, and that reference, it varies from one organization and one team to the other. But for the engineers, usually they say something called like a vector kind of value, vector record. It basically helps engineers say, okay, when this request came in, each one of them has this value that says this is for the request number one. So this is processing for request number one. This is persistence for request number one. So when this customer comes and use a software, the first question the engineers are going to investigate is, oh, let me see what your request, vertices or indication number of the issue is. And based on that number, they're going to go and query this logging records to find out exactly what happened. So this guy is saying, my record did not work, but when the engineers go in there, they will say, no, actually, your request have been successfully persisted because the records that we're collecting about every activity in our system says that something successful has happened to your request, right? Any questions about this one?
It's clear. Thanks.
Now, sometimes it's not all bunnies and rainbows out there. Sometimes request number two will come in like
Mhm.
this, but request number two, what's going to happen to request number two? Request number two is going to fail, right? So this request that's coming in, so this is request received, request number two, and then request process number two, and boom, this one failed. So again, another customer comes in and says, hey, how come, something failed? The engineers go and start, spectating, right? And they go and say, what happened? Let's see what happened to our system. So I'm looking with a little magnifier here and I'm trying to investigate everything. And I realized, oh, hold on a second, we have a failure in here, right? And then this failure is supposed to contain all the details, all the information that we need to understand why this guy's request didn't succeed.
Mhm.
So this is where these beautiful exceptions that we've been building come in handy. If it says not found exceptions, we know exactly why the problem is before you even read any additional details. Every exception that we create tell us what and where and why. How?
Mhm.
It tells us what happened, right? What happened is that an error occurred on, on the student entity. Where? In the foundation service. Why? Because the item was not found. So when you read our exceptions, the way we build our exceptions, you'll see this. You'll see us saying not found, right? Student exception, right? We do this.
Mm. Right.
So this portion here, this little portion here basically tells me what? It tells me what the problem is. And this guy tells me where the problem is, which entity that
Mhm.
have caused this issue to happen, right? And then you have on top of that, when there is nothing here in the exception, it basically says, yeah, you're at the foundation level, but you'll see something like this, not found student processing. Check this out. You will see in other services, let me just do this. Oh my God. Processing exception. Like if there is no processing or orchestration, yeah, we all know that, okay, this means he's in the validation. He's in the foundation area. But this here will tell me what? It will tell me where this happened, where it happened. So the name of the exception is designed in the standard to help you answer these questions. What happened? This is why we have a failure, right? And this will tell me what entity is impacted by this. So this is what. It's the name. And this one here will tell me where this exception happened. See, so the name of the exception itself tells you everything you need. And the only thing you need in addition to that is just the additional details, like what's the ID, which person, that's it. And that's why we have these input parameters where we go and say, oh, the ID is this and the reason is that. What do you think?
No, it's clear.
Okay, so
Very
what? Yeah,
beautiful. I would say
right.
very.
Everything has a reason, right? Not found student exception, why, what, where. So that means when Sally is supporting some large enterprise, some 100 million user system, it'll take literally Sally 2 seconds, 2 seconds to determine what, where, why immediately. Bang, 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 just like that. And the only thing that's left, specifics, like what the idea is. Does that make sense? And this is why a lot of people come in and ask me this question. They say to me, Hassan, why don't you just create not found exception? Just not found exception like this, and just reuse that model wherever you want to go. I say to them, simply because if I use one model, now I have already created coupling on the model level between different entities. But not just that, the other problem here is that now you stripped down my exception model from telling me other information that are important for me to know about from first glance. First glance. The logging comes in handy when it goes and does this. The logging will tell me two things that are really, really important. There's a question here that engineers really care about, which is when. So the logging will go and say in hour 12 minute 53, this issue happened. That's the first question. This is where logging comes in and help me with that. And it will also help me answer another question, right? This is the other vertical kind of thing of information that I need to know, which is who, why, what, where, when, and who. When did it happen and who did it affect? What do you think about that?
This is also similar. Okay, I got it.
Unfortunately, we couldn't actually, have it baked in the who and where and when. We couldn't bake it in the who and when because they're variables. They change all the time. But the what, when, where, they're stuck in there. If the issue happens, it will always be not found. It will always be in the processing service. It'll always be the student entity. Better listen up. They won't teach you this in college. You won't see this in any book. I promise you that. This is just the simplification, the best I can put out there when it comes to this explanation. When there is no exception that's happening in any system, logging takes over the responsibility of telling you the where part. It will go and say, hey, no exception really happened, but when this service, when this entity, when this request went through the foundation service, it was processed successfully for a student entity at minute 53. What that basically means is that there are levels of logging. Sometimes it's not really a big issue. It's just concerning. Like sometimes you'll see another system in here that goes and says, check this out. Logging has levels. Sometimes everything is good and dandy, but there's something suspicious. It's not too bad, it's just suspicious. A warning that you want to put out there. What's an example of a warning? Normally, a request should not take more than, let's say, 2 seconds. This request took 5 seconds. It could be a big deal. It could be nothing. Just like everything in the world, there are things that are absolutely bad. There are things that are absolutely good. And there is a whole shades, the whole different shades of colors in between about the things that are maybe bad, maybe good. Sometimes they're bad if 1, 2, 3 happens, leaning more towards bad and leaning more towards good. In programming, it's much more obvious than that. Like in the real world, it's not very obvious. It's a kind of gray area. That's what people say. It's a gray area. I don't know. In programming, it's much more exciting than that. In programming, you go and say, well, this request took too long, but it's not long enough that I would lose some sleep over it. This is what we call a warning. So we have right now the types. We have trace, and we have, that's the green. All green is trace, telling me what happened, right? So this is trace, like this, trace. And then we have error, red, right? And then we have warning. Nothing big, just a warning. Something that may or may not be a problematic situation. What else is out there? I'll tell you what else is out there. Sometimes the engineers will go in. Now these guys have children, and I'll tell you what these children do. Trace has a child of its own that it's called information. Information is not even something that you're tracing. It's just you going and saying, hey, I every time someone comes into the system, I'm not really tracing them. Just print out this logging as an informational, and it's very rarely used. Trace, did I say trance? It's trace. Trace, like this. Trance music, trace. Okay. Error has a child that's really, really cantankerous. Has a very, very ugly child. And the child here is called critical. So sometimes there's errors that's request wise, and sometimes there's critical errors, meaning the entire system, the world is on fire, basically. Information has a child, and that child is called debug. Debug. Debug is basically engineers going out there saying, hey, just for the time being, and I'm going to remove this later, I want to know the content of the particular request that is being passed. Debug should not stay in your production code. There's trace, error, warning. Warning doesn't have children, just warning. But error has critical, and trace has information and debug. And engineers use this kind of interchangeably. They switch back and forth between those all the time. All right. So let's bring that all in on the ground. Let's go down here and say, well, here's Sally library. Let's start from the top. Void. What's the least, scary of them all is information. You start from the lowest to the highest, and then there's something like, there's information, there's just debug. We're just checking things out. There is a message, right? And then there is void. There's also log, trace, like this. And what's a little bit bigger than trace? There's warning. And then log error. And then at the very end here, there's log critical. 1, 2, 3, 4, 5, 6. So that means we go up in here and we basically implement that. So I go and say iLogging broker, control period. It will spit out all these functions. I'm taking in a constructor in here that takes an iLogger, Microsoft logging extensions. And there's so many different libraries out there that compete for logging. So this is my logger in here. I'll explain that to you later in the game. But for now, all I really want you to know is that this iLogger basically here, private read-only logger, just like this. And all we really do is just we go and just use it. So in here I would say logger dot log critical. Log critical. Look at all the types. Do you see them? There's log critical, debug, error, information, trace, warning. These are all the ones that engineers could come up with. There's just log, but I don't know what like log basically is you going and saying the log level like this, and you determine based on the level. There's warning, critical, debug, error, information, pretty much the same thing. There's one in here though that's interesting that I've never heard about before, which is none. I don't know what the heck that is. I think it's just the absence of no value. So let's implement those real quick. So log critical, right? And log critical wants a message, so I can go here and say, hey, here's the message and here's an exception. Easy. Right? Let's go up in here and say log debug this dot logger and then debug, right? And here is your message. Done. Okay. What about this one? Log error. Oh, I need an exception now. So it's logger, log error, right? And this guy takes a message, so the exception dot message and the exception itself. And it will take care of handling stack trace. What about information? Same thing. This dot log logger dot log information. And here is the message. Done. Let's go to trace. There you go. This dot logger, log trace, message done. Log warning, same thing. This dot logger. Boom, 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 like this, logger. Log trace. And then pass in a message. That's it. There you go. Right. So that's the logging stuff. We can basically put a hold in here. The one thing I would ask you to do really as an assignment today is to basically look up OSSS and see how we used these loggings, this logging functionality. That means we need to add this as a new dependency in the book service. So now instead of us saying, iStorage broker, now we're going to have to go and say private read only, I logging broker, logging broker. That's it. Your assignment today would be this: to define a logging broker and to pass it in as an input, just like we did with the storage broker, and just make sure the tests pass. I don't want you to use it. All I want you to do is to incorporate the logging broker just at the definition or the instantiation of the book service. That is all. So brokers, logging, broker, like this.
So can you
Okay.
repeat the question again?
What's
So,
required? You see how we added this as a dependency in here? All
mhm,
I want you to do is to add the logging exactly the same and fix the tests. Because as soon as you add a new dependency here, the tests are going to fail because your constructor used to request only one input and now you need two inputs.
right. You have to add them all. Okay.
Yeah. Is that clear? Good.
Yes.
All
Perfect.
right. All right.
Thank
I hope this was useful. Thank you so much again. Thank you guys for watching. Thank you, Sally, for your patience. And let's connect again tomorrow.
you
Okay?
for your time. Have a good night.
Absolutely. Bye.